the first thing that happens, I think in most people, you can probably become insulin resistant in your muscle tissue first if you just like sit all day and do not move that muscle at all. But generally, I think the fat becomes insulin resistant first. Then it starts turning over fatty acids like we talked about before. These go through the portal circulation to the liver. All this stuff just starts showing up, and the liver starts saying, fine, I just have to start turning this stuff into glucose. And that's kind of, that's where the whole thing starts.
Welcome to the Fundamental Health Podcast. I'm your host, Dr. Paul Saladino. This podcast is the result of my relentless search to understand and correct the roots of chronic disease and illness. In this podcast, I will share with you everything I have learned about how to live the most healthy and radical life possible. Thanks for joining me on this journey. What is up, you guys? Oh my goodness, I am getting so excited. When this podcast releases on the 21st of July, we are now 2 weeks, T-minus 2 weeks, 14 days from the official release of the second edition of my book, The Carnivore Code. I am so stoked about this. If you have not pre-ordered your copy of the book, you can do so, thecarnivorecodebook.com. You can do it on Amazon. You can do it on other retailers that you prefer. We are working on getting that audiobook up for pre-order. Audible has been backlogged, and believe me, I have had a lot of requests for this. So if you want to pre-order the audiobook, stay tuned. It is coming. You can get print and ebook at all those places, thecarnivorecodebook.com. We are 2 weeks away. Thank you to all who have pre-ordered thus far. For anyone who pre-orders, I am offering a special thank you, which is a private video, a secret, surreptitious, occult, hidden video on YouTube on how to eat a carnivore diet. And I will send you the link for that if you pre-order the book. On my newsletter, which you can subscribe for at carnivoremd.com, you will see the link for the pre-order bonuses. I will also invite everyone who pre-orders to a live private Q&A with me after the book releases. So thecarnivorecodebook.com. You can go to my website, CarnivoreMD, to sign up for my newsletter, and that will get you in a good spot for all the exciting stuff that is coming up, you guys. I'm so freaking stoked. This week on the podcast, I have a very special treat for you all. This is part one of a two-part extravaganza with one of my favorite people in the whole world, Dr. Tommy Wood. You've heard him on previous podcasts. This is the third and fourth podcast that I have recorded with him. This first week, we are talking in January, at the end of January 2020, before COVID happened. Tommy and I sat down in person in Scottsdale at a conference that I went to and spoke at that he was hosting, the Physicians for Ancestral Health Conference. And we talked about all kinds of things. We talked about coffee, longevity, ketogenic diets, and insulin resistance. And then next week on the podcast, you can hear the conversation that I had with Tommy just this past week in July 2020, sort of during COVID. Tommy wrote an article, an editorial about the importance of metabolic health in pandemics. And we went into tons of detail about that and got really, really granular into the molecular mechanisms of insulin resistance and what is causing it. Polyunsaturated fatty acids are an interesting culprit. We go really deep into that idea. The PUFA ideas I've been talking about, PUFA, polyunsaturated fatty acids, and we also talk about fructose. That is all next week. This week is part one. Next week is part two. These are two bookended conversations about insulin resistance, really what is at the center of our chronic disease epidemic with Tommy Wood. One is pre-COVID, one is during/post-COVID, and they are going to blow your mind. So thank you for listening to these. Check Dr. Tommy Wood out at Dr. Tommy Wood on Instagram. Give him a what's up. He's one of my favorite people in the whole world. He's an MD, PhD, and you can hear he has an amazing accent. He is a researcher at the University of Washington. And as I said, this is the third and fourth podcast we have done together. The first one was a hit. It was on all kinds of cool stuff, including a little bit on insulin resistance, a little bit on sex hormone binding globulin. And then the second one was on ApoE4. And again, these two are on insulin resistance. Thank you to my sponsors. So appreciate my sponsors. Got to give a shout out to NutriSense, nutrisense.io. You guys know them. These are the folks I did my CGM with. I appreciate them so much. I learned so much from the CGM. It showed me that when I eat a reasonable, not a huge amount of fructose in my diet in the form of honey or fruit, I did not get insulin resistant. Imagine that. You can see that in my glycemic variability, my baselines. If you want to see that episode, it's previously on my podcast, and you can see it on YouTube if you actually want to see my blood sugar readings when I included carbs. If you want to know why I did that, listen to that podcast and learn a ton. You can check out nutrisense.io on the web to get a CGM for yourself. My dad is going to wear one of these. I'm so excited to see how it will help him make behavioral changes. Real-time feedback of your blood sugars, I think, is going to be a game changer for behavioral change for people. You don't want a lot of glycemic variability. It's not the end of the world if you have a glucose bump with carbohydrates. That's normal, and I would argue evolutionarily consistent, probably beneficial from time to time. But what you really want to make sure of is that you don't have a huge glycemic response or lots of glycemic variability, and that is where a CGM is paramount. So important. So check out nutrisense.io. Also want to give a shout out to the folks at Force of Nature Meats, forceofnature.com. I love these folks. They are connected with the awesome people at Rome Ranch. These guys are sourcing amazing regenerative meat from the US and New Zealand. You can get ground elk, ground venison, ground lamb, ground bison, ground beef, and you can get organ grinds. They have some amazing stuff. Check out forceofnature.com to support the regenerative agriculture movement. I love these guys. They're doing amazing, amazing things. You guys all know my homies at White Oak Pastures, whiteoakpastures.com. My goodness, these guys are amazing. They're really the originators or some of the pioneers in this world. 150-year family farm, last 20 years regeneratively raised. Will Harris, Jenny Harris, these guys are astronaut pioneers. They are regenerative pirates in the best sense. They're the good kind of pirate, not the bad kind of pirate. But most pirates are good at heart, I think. Anyway, Will Harris, Jenny Harris, love them. whiteoakpastures.com. Regeneratively raised meat, rotational grazing, carbon negative via life cycle analysis. Amazing stuff. Use the code CarnivoreMD there for 10% off your first order. And get your organs, get your beef suet. Leave me a little bit of suet, please, because I love it. Get your bones, make your bone broth, and make yourself a radical human. Reclaim that ancestral birthright to radical health, my people. White Oak Pastures is going to help you do it. And it looks like they are rolling out some kind of a new loyalty program that you should check out as well. I'm excited to hear what they are doing there. If you like this podcast, please support my efforts to share this good word with other people. This is how we change the world, you guys. This is how we let people know that there's a lot of untruth out there. And I strongly believe that eating animal foods as the centerpiece of our diet, understanding which plant foods are harming us, will change the world and will bring so many of our brothers and sisters, children, family, mamas and papas, grandmas and grandpas, and ourselves back to amazing health, radical health. So please leave this podcast a review on iTunes. Thank you for your support. If you have read my book, The Carnivore Code, please leave me a review on Amazon. It is crushing it. 525 or so reviews. I cannot wait for this thing to go in the second edition, thecarnivorecodebook.com. It's going to crush it, and we are going to help a lot of people. So thank you all for your support. Without further ado, on to the podcast. Listen after for what is going on with me. We're live. Tommy Wood, what's up, my man?
Hey, man.
This is going to be the Ask Tommy Anything podcast because I've done AMAs and I'm so stoked to be hanging out with you here in Scottsdale for at least a few days. And I've got lots of questions for you. We've had lots of talks in the interim. I so appreciate all of your help and sort of collegial co-thinking, but it's fun to be here with you and we can rap about all kinds of good stuff.
Yeah, I'm excited to talk again. It's been great to hang out some more and see each other. I'm sad that you left Seattle, so
I know.
So
right?
It's nice to catch up.
We played some shoulder tag yesterday in the movement session.
Yeah.
Good bro bonding. All right, so let's start with this. You said, "All right, come over to my little. You got like this villa here at the hotel. Come over to my villa. I'm poisoning my adenosine receptors. Tell me what you were doing this morning as you were poisoning your adenosine receptors."
Yeah, so I'm a big coffee fan, and I've become a bit of a coffee nerd. And so just making sure that if I drink coffee, I like it to be high quality and to taste good, which most coffee doesn't. So I took a nice morning walk through the old town of Scottsdale and went to a local coffee shop where they sort of roast their own beans and got something to poison my adenosine receptors, so I'll be nice and awake to talk to you right now.
So people may not know the mechanism of caffeine. How does it work in the human body?
Yeah, so I mean, it has a large number of different molecules that have potentially bioactive properties, but the main one we think about as an adenosine receptor antagonist. So when we're thinking about what makes us sleepy or wakeful during the day, particularly, there's a buildup of adenosine, and that's what partly or largely creates a drive to sleep in the evening. And caffeine is an antagonist for adenosine, and that's part of the reason why it helps wake you up.
And there are other compounds in the same family as caffeine, methylxanthines, that can do the same thing, right?
Yeah, so you'll see related compounds in tea, chocolate, that have slightly different structures but largely similar properties. Although some people respond to them differently. So many people say that the theobromine in chocolate affects them less than, say, the xanthines in coffee or the in tea.
Slightly different molecules.
Yeah, and if physicians might recognize theophylline, which is in tea, which is actually used clinically in some respiratory disorders. It can help with like acute asthma attacks and things.
When I was a kid, I had asthma because I lived in Washington, D.C. and ate a lot of dairy, and who knows why. I also had a bad eczema. And my parents would put Theodore, which is theophylline, in my applesauce.
Really?
I remember this fondly.
You're chronically stimulated.
It was like, oh my God, this is the way we used to treat asthma, was with Theodore, which with theophylline. And I also had way too many puffs on my albuterol inhalers and these, beta agonists, these inhaled beta agonists. So people always ask me about coffee. I don't think this is going to be the full coffee podcast, but I at least wanted to offer my thoughts, and then I'll let you offer your thoughts on coffee. I'm not sure with coffee. Certainly, this is one of these plant compounds that I'm not a huge fan of for a variety of reasons. Certainly, caffeine can be a stimulant. We were joking when we lifted the first day. You're like, I'm going to go get some caffeine. It's going to kill me. And I said, it's a phytoalexin, and at the doses that most of us consume it, I don't consume caffeine, but at the doses that most humans consume it, it's probably not going to kill anyone. But there actually is. I mean, there's an LD50, a lethal dose 50 for basically everything we have.
Yeah, absolutely.
There's an LD50 for salt, probably. There's an LD50 for water, but there's an LD50 for coffee, and it's as far as I can tell.
For caffeine, I think it's like 500 milligrams per kilo or something like that.
It's quite a bit.
Yeah.
And when I did the research for my book, the calculation I came up with was 75 cups of coffee. So you're probably 73 cups away from...
And LD50 is the amount needed to kill 50% of people.
Right.
Yeah.
So it couldn't kill you. you're 73 cups of coffee away. But in the plant kingdom, caffeine, it appears to have been developed as a factor to dissuade animals from eating these plants, from eating these seeds, and humans are kind of leveraging subtherapeutic doses. So one of the concerns that I have about coffee is the associated polyphenols. And you and I kind of have friendly disagreements about this. But in the book, I talk about a few papers having to do with the polyphenols in coffee. Most of the world feels like the polyphenols in coffee are good for us. And, many people would say that the polyphenols in coffee are where most people in Western society get the majority of their polyphenols. Yeah. And I think one of the more controversial, contrarian things that I think about sometimes is that maybe these polyphenols are not great for humans. I've recently started talking about my polyphenol deficiency syndrome, which is quite debilitating, results in lots of energy and good mood and stable moods and pretty good body composition and stuff. That's what you get with a polyphenol deficiency. But, in one of the papers that I talk about a lot with Bruce Ames, his paper on plant pesticides, he notes that roasted coffee is known to contain 826 volatile chemicals, 21 have been tested chronically, and 16 are rodent carcinogens, including caffeic acid and chlorogenic acid. A cup of coffee contains at least 10 milligrams or 40 parts per million of rodent carcinogens, which is mostly caffeic acid. He says catechol, furfural, never heard of that one, hydroquinone, and hydrogen peroxide. So my question's becoming, like, how do these affect us? Who knows? Are these subtherapeutic doses? Are they hormetics? Do they have these kind of side effect profile things? I've started talking about package inserts. And this is one of the things I wonder about. And I'll just mention this study and a couple more things, and then I'll get your thoughts. Louise Menon has a study where she says some polyphenols may have carcinogenic or genotoxic effects at high doses. Caffeic acid, for example, when present at a 2% level in the diet, induced 4 stomach and kidney tumors in rats and mice. Linear extrapolation of these data indicates appreciable risk at normal levels. So I thought, well, that's interesting. I think we don't know here, but the question is, could some of these polyphenols be doing negative things in humans, potentially breaking DNA and cell culture? The other issues I have with coffee, I won't belabor this point, are the acrylamide from the roasting process and maybe the mycotoxins. If you're getting organic coffee, it's probably less likely that that's going to happen, and any pesticides that are on the coffee. So a number of things. So people always ask me, the only reason I'm saying this is just that people always ask me, what's the problem with coffee? Will you talk about coffee? In the book, I talk about those things. Acrylamide, probable human carcinogen, not totally clear, but it's labeled as a class 2A carcinogen by the National Cancer Institute. And apparently in California, there was a ruling that 7-Eleven stores have to place a Prop 65 warning on their coffee because of acrylamide.
Everything causes cancer in California.
True. I know.
So
only in California. I'm curious for your thoughts about that kind of stuff. I think that the overarching theme here is we don't really know, but that's at least just so people know my thoughts on coffee. That's the short answer for me. And I'll be curious what you think of all that.
Yeah. I mean, I think when you're talking about this stuff, it's so easy to focus on, individual effects of high doses of individual compounds in rat studies. And yeah, I find that interesting. The problem is, I think it's difficult to appreciate what a rat study entails unless you're somebody who actually does them. And I am somebody who does them. Like that forms a majority of my life. It pays my salary. And it's almost impossible to really do anything in a rat that you are confident is going to translate to a human. And that's why thousands of different treatments for different disorders, different diseases they work great in a rat and they just do not work in humans. So
resveratrol.
Yeah. Resveratrol is a great one. Obviously I focus on brain injury, and my field is littered with drugs that never succeeded in human trials, either because the dose doesn't work, the drug doesn't work in humans, or the doses don't translate, the drug doesn't get where it's supposed to go. There's numerous reasons for it. And so I always find that stuff super interesting. But I always then think and we've talked about this a lot, where's the signal in the human, right? Where's the signal in the human that coffee is good or bad? And you'll find plenty of studies saying that, coffee up to 5 cups a day is associated with reduced Alzheimer's disease, I think fatty liver disease. And this is nutritional epidemiology. One thing which neither of us are a big fan of. One thing that you could say is that it's easier to remember how often and how much coffee you drink rather than how many tablespoons of heavy cream you had on average for the last year, right? Which is what Walter Willett will ask you in the nurse's health study or the health professional follow-up study. So the signal in humans, I'm not sure it really exists. There was a paper that came out that recently that said it was coffee was only associated with a benefit if it was brewed with a paper filter rather than a metal filter, because the paper filter does absorb some of those polyphenols and then they don't end up in the cup. The problem is that most coffee worldwide is brewed with a paper filter. However, I usually brew my coffee with a metal filter because I prefer the taste of it that way. So I may well be doing all these terrible things to myself. I don't truly believe it because of all the other stuff that I make sure to do in my life. I think that something like that, it's going to move the needle so little that I don't believe. I think it's just going to be largely neutral. But things that I do is I make sure that it's high quality coffee. I usually have a much lighter roast. So the really dark roast coffees, if you are worried about acrylamides, I don't know how much that's really going to change things compared to the big fat steak that I had that was cooked at a high temperature last night. How much should I worry about that relative to my coffee? Not really sure. The mycotoxin thing, I think that this is basically just a marketing ploy by Dave Asprey. And it's, there are going to be these things in coffees. And again, I actually I prefer coffees that probably have a higher risk of a mycotoxin problem because they're naturally processed, which is when you get the coffee cherry, there's all this pulp on the outside, and that coffee, natural processed coffee, is dried inside the cherry. So it has all this like moist, good, juicy, sweet stuff that, mold is going to love to grow in. So natural processed coffees are much more likely to be spoiled from mold. However, that also means that the producers are super, super careful to make sure that if that's happening, it's not detectable. Am I worried about that? No, not really, because I really enjoy the flavor, and I think there are some. I think this is my general thoughts on many of the things that people are worried about, and actually it goes the same for a lot of plant toxins, plant polyphenols. Is that we have a physiology that I believe is adapted to consume these things and deal with them even if they're not beneficial. I think a lot of plants are just largely neutral. That's where I'd lie. And I think that, we have eaten them in varying amounts throughout our evolution. And if they were things that would debilitate us in any significant manner, we wouldn't have been able to survive where we are today. So I think if these are things, and molds are the same, right? Mold is everywhere, right? And it has its own special flavor when it's in water damaged buildings, and there's a modern component there, but this is stuff that we should be able to have some of and deal with and go straight on. And if we can't deal with them, for me, so if you can't deal with plants, you can't deal with coffee because it's got some mold toxins in it. That tells me there's something else that you haven't fixed. There's something about your physiology that isn't quite working properly. Whether we know how to fix that is another matter. But I think these are things that we have been exposed to, and we should be able to have some of them without any problem.
It's interesting. There's an article, I can try and pull it up, that I think it's pretty reasonable hypothesis to suggest that the cytochrome P450 systems developed in response to plant toxins.
Yeah.
That throughout animal evolution, that this whole system of phase 1 and phase 2 detoxification, specifically phase 1 detoxification, developed in response to plant toxins as part of this warring process. And so plants are developing toxins, and the animals are like, hey, I need to detoxify those. Mm-hmm. So we have some system. And I think that you're right, that we have some system in place to detoxify these things. The question is, how much is too much and overwhelms it? And where's the net benefit versus net loss? And we were at dinner the other night as I was asking the waiter or waitress about what the hamburgers were cooked in. And she said, soybean oil. And I said, are you kidding? And then she said, oh, it's cottonseed oil. And I said, give me a break. Don't cook it any of that. But anyway, we were talking about, is there anything that's truly neutral? This is a kind of a philosophical question. Mm-hmm. Can a plant toxin be neutral? Can plants be neutral? Are they only good or bad? Is this too much black and white thinking? I don't think we know. But I do think that humans have an ability to detoxify some of this stuff. And we wonder, is some of it overwhelming it? Is there, if we intake too much, could it be some of it get through? And as we've seen with some of these other molecules, which I think is quite interesting, what about the stuff that doesn't get detoxified immediately and circulates in the body? Could it be causing kind of havoc elsewhere until it gets detoxified? I think there's a lot of nuance here that we don't totally know about. And you're right, the signal is hard to tease out, how much of these plants are hurting people or not. At an individual level with a carnivore diet, I definitely see people who get better when they eliminate plants sometimes. And you've got to wonder, are they just uniquely sensitive?
Yeah.
Were they just eating way too much? Is it a dose thing? Is it an individual thing? Are some people more or less sensitive? Like you said, I think there are definitely some mechanisms to detoxify, but at some level, how do we overwhelm? Or are there these other collateral damaging effects that we're missing? It's an interesting question.
Yeah, so the cytochrome P450 system is one of the systems where genetics has a predictable effect, where actually you can say, maybe you're going to do more or less with this compound. So your CYP2A1 detoxifies caffeine, right? So then, they've done, that's probably one of the areas where they've done, and drug metabolism with genetic SNPs in that area, they've done some good research because pharmaceutical companies are interested in it. So that's definitely something where there's going to be some individuality that you can predict to an extent. But I would worry more about more recent novel compounds that our physiology hasn't been exposed to. So if you're talking about all the plastics and the phthalates and those kinds of things, that we have been exposed to those for a much shorter period of time. So if you're thinking about something that the body is potentially less capable of handling, that's an area where I potentially worry more.
And then this makes me think of regional variation in our genetics, which gets to sort of incomprehensible levels of complexity.
Yeah.
You're a Norwegian Viking. Maybe your ancestors were exposed to certain polyphenols that they could detoxify, but if you have equatorial polyphenols, you're like, what the heck is this? I've never seen it.
Yeah,
right?
That's possible.
And then that is uniquely going to slip through the defenses. So, and I think at this point in our evolution, it's quite hard to really tease that out. No one will ever be able to do that. Perhaps I will be proven wrong. There are lots of genetics companies, which we can talk about, who are claiming to be able to do things of that sort, but I think that's complete conjecture and totally falsehood. Everyone is too genetically mixed, and that's probably a good thing now.
Yeah.
As you and I have talked about, there are studies in fruit flies which suggest that it takes 25 generations to have a genetic change, maybe 1,000 years. So perhaps if someone were from a, quote, simple, clear genetic stock or lineage, if all your ancestors were from Iceland, and they were just all clearly just Vikings, then maybe that was a very specific place. But in today's world, most people are mixed with people from other parts of the world, and we can't say like, these are your ancestral foods. These are the foods your ancestors have been eating. These are the compounds in these foods that your detoxification systems have been evolving to deal with. But I think it's an interesting question, how uniquely suited we are to deal with different molecules from different plants in different parts of the world. Maybe this is one of the applications of a carnivore diet, at least at the start. Cut it all out.
Yeah.
Eat the foods that don't appear to have these intrinsic plant toxins, and then bring them back in as you want to see which ones trigger you. Maybe that's kind of the filter that we move forward with. It's an interesting concept.
I mean, I'm a big fan of elimination diets, and where you eliminate to will differ from person to person. I have no problem with eliminating all plant foods and then adding them back one by one and seeing how you respond. I think a well-formulated elimination diet is one of the best tools we have, particularly in like the rheumatological arena. It was the original treatment for rheumatological disorders. Back in the 60s and 70s, they were doing elimination diets because they hadn't invented monoclonal antibodies yet. So, and I think that's, for a lot of people, that's where you should return to. So it's certainly possible. I don't think it's a reason to just throw up our hands and say, oh, well, we don't know which polyphenols we can take, so let's just not have any. And I think that I truly believe that we should have capacity to deal with those things.
Some people more than others, or different molecules.
Yeah.
And I love that you said a well-formulated elimination diet. I'm just going to put words in your mouth. And what Tommy is talking about is a well-formulated carnivore diet. He's not, I'm joking. But I'm going to quote something that you told me one time. You said, maybe I'll do a carnivore diet when I'm older.
Yeah.
He said, I'm going to eat a carnivore-ish diet. Whenever I get people on the podcast, I try to tell them they're eating a carnivore-ish diet, whether or not they are. I had Lucy on the podcast last night, and I was like, you're eating a carnivore-ish diet. And she was like, well, but you kind of eat a carnivore-ish diet. I mean, I would define a carnivore-ish diet as the majority of your nutrients coming from animal foods with some plant foods that are considered along some spectrum of plant toxicity. So, and I just want to note for people on the record, Tommy has said that he may eat a carnivore diet at some point in his life. And he thinks that would be a reasonable thing.
Yeah.
Am I right?
Well, I think getting most of my nutrients from animal foods is the right thing to do. I think that's where most of your nutrients can and should come from. My problem with very low carbohydrate diets is that I cannot eat enough. I just am not hungry, and I can't maintain muscle mass. And at this point in my life, that's still important to me. So I've tried it multiple times, and I just can't do it. So while I'm still trying to work hard in the gym, I'm including some plant foods because they have more carbohydrates in them.
And let's break that down a little bit for people, because this is a quite interesting thing. Do you think that is an absence of calories or an absence of carbohydrates that is limiting you in that state?
Yeah, that's a good question. I think it's largely an absence of calories, or a deficit of calories, and it's purely driven by the amount of hunger that I have. And when you look at ketogenic diets in athletes, and they're doing like more and more studies, and some of them are really terrible science, but some of them are decent. And what I think seems to fall out once you've kind of looked across all the different studies is that if you do a decent ketogenic diet in an athlete, and there are probably going to be some elite athletes where this doesn't apply, because those these generally aren't done in elite athletes. But if you just want to be somebody who performs at your given sport and fairly well, if you do a ketogenic diet properly and you give enough time to adapt, it doesn't really make any difference to your performance. And in some studies, probably because they're increasing protein, maybe they've put them in a short-term caloric deficit. Body mass, body composition may improve slightly. So I'm not that worried about a ketogenic diet and performance. Again, for some elite athletes, that may change. But for the average person like me, I'm not super strong. Like, I'm not competing. I just like to go and lift heavy things in the gym. I don't think that as long as I have a eukaloric, I would perform just fine.
One of the things that you highlighted for me was that insulin is not anabolic.
Yeah.
It's anti-catabolic. And I thought that was so interesting. And you've given me a couple of studies showing that carbohydrate addition does not necessarily enhance muscle anabolism or strength. And I'll just mention a couple of those. But what we're talking about here is that within strength communities, because a lot of us are interested in strength, whether we're bodybuilders or we just like to be strong, which is a good thing, there's kind of this question, which has almost become accepted as canon, though I think we should question it, that we need carbs to be as strong as possible. And that sort of infers that insulin, presumably related to higher levels of insulin with carbohydrate spikes, is somehow anabolic. Mm-hmm. But you highlighted to me that it's not. It's really just anti-catabolic. And so what you're saying here is something that I've been thinking about recently, that if we fill our glycogen stores with adequate amounts of protein and we have enough creatine from muscle meat, does it look theoretically like we would potentially be any weaker without carbohydrates in our diet? And I don't think so. But again, I'm not an elite strength athlete. I did a podcast with Stan Efferding, and we talked about this, but I'm waiting for the keto strongman, quote unquote.
Yeah.
Now, of course, the nuance here is you have to get enough protein, and you have to get enough protein to fill your glycogen stores. A lot of ketogenic diets are too low protein to do that. I think that's where people see muscle mass loss. I'm on what I would consider to be a low-level ketogenic diet with a carnivore diet. I don't track ketones. I eat a lot of protein in a day, about 1 gram of protein per pound of body weight. And I think at that level, our glycogen stores are full, which is what we would see in the FASTER study. Mm-hmm. The FASTER study, they ate 2.1 grams of protein per kilogram, or about 1 gram of protein per pound of body weight, and they showed equivalent levels of glycogen storage and repletion. So at that level, 1 gram of protein per pound of body weight, it looks like glycogen is full.
And if you're doing resistance training, it's actually, you don't move the needle on your glycogen stores that much. Your liver certainly, but not in your muscles. You have to do several sets to failure with short rest periods to really, reduce glycogen stores in the muscle. And even then, you're only getting down to like 60, 70%. So, it's almost impossible to completely deplete the glycogen. So, I'm not particularly concerned about glycogen. But I will say that studies that would look at this and do it well really haven't been done. So it's a scenario where I don't know. There is plenty in the academic sports science literature to suggest that carbohydrates are ergogenic. They improve performance in various different sports. But if you're comparing that to somebody who's keto adapted for an adequate period of time and started out with the same level of performance to begin with, do they then see a decrement in performance? Would they benefit from very small amounts of carbohydrate during the event? My guess is maybe, probably, but those studies don't exist yet. So it's basically conjecture.
We don't know. So this study, addition of carbohydrate or alanine to an essential amino acid mixture does not enhance human skeletal muscle protein anabolism. One of these things that just shows that, hey, when you add carbohydrate, you don't get enhanced muscle protein synthesis. So carbohydrate is probably not triggering muscle protein synthesis.
It is worth mentioning that muscle protein synthesis measured in the lab, like if you take a muscle biopsy and you measure the amount of muscle protein synthesis or the amount that pathway has been activated, that doesn't necessarily translate to how big and jacked you are eventually going to get. So I think adequate protein, reaching that somewhere near a leucine threshold throughout the day, the 24-hour period after going and lifting weights, that's probably going to be enough as long as you have adequate calories on board.
Adequate calories. And by leucine threshold, are you talking per meal? Because the numbers I've seen are 2.6 grams of leucine per meal to get muscle protein synthesis. Are you thinking about a global leucine threshold for the day or an individual meal leucine threshold?
Yeah, so you can you can definitely get down into like the nitty gritty and the real like bodybuilding nerds will have like a specific amount, and it's well, you're basically talking 2 to 3 grams of leucine per meal, 3 to 4 times a day, something like that. And you can adjust it by body weight as well. But if you're just somebody who wants to perform well in a given sport, particularly if you're trying to improve your body composition, increase lean mass, I think just making sure that you're getting about half a gram per kilo of quality protein, animal-based protein, essentially 3 to 4 times a day. That's probably going to be enough. You don't need to worry about the individual amino acids.
Exactly. And so what Tommy's saying here is we're saying the same thing. I'll just clarify for people. With about 4 ounces of high quality animal protein, you will get that 2.6-ish gram leucine threshold and trigger muscle protein synthesis. So those who are looking to gain muscle, whether you are including carbohydrates or not in your diet, would want to do that. You would want to eat multiple times per day, do resistance exercise, and have each of those meals have at least 4 ounces of high quality animal protein. One of the things that I talked about with Gabrielle Lyon recently is that number might be more dependent on blood volume than overall weight. She was talking to Don Layman about that. So I thought that was interesting, that even for smaller individuals, that number might be similar, because even smaller individuals, we don't have as much variation in our blood volume between us. You and I might both have a similar blood volume, even though you're a bigger human. So even smaller individuals might need that large amount, and larger individuals might still get muscle protein synthesis at a 2.6-ish gram leucine threshold.
Yeah, I mean, that's certainly possible, and I have no problem with people eating that much protein. I think that the real reason why that is important is because there are a lot of scenarios where people are recommending much smaller protein doses for smaller people and smaller older people, and I think that is a bad idea.
Stephen Gundry.
Yeah. So so that kind of thing is important, just to make sure that particularly smaller, older, sarcopenic people who are worried about their long-term health aren't then protein restricting because they think that's going to benefit them. I'm sure it won't. So yeah, I think it's easy to be like, oh, well, we can adjust for a different factor. And again, I think that's interesting. Is it useful? I think it's only useful if you're just using that information to say, yes, this smaller person shouldn't be restricting protein because of some like weight-based calculation.
Are you saying that animal protein isn't going to shorten our lives, Tommy?
That is what I'm saying. I am fairly confident that that's the case.
Well, this is a great segue to the next topic, which is super interesting and comes up a lot. I want to demystify this for people. As we're talking about low carbohydrate diets, let's dig into physiologic insulin resistance. So you and I talked a lot before I did the podcast with the folks from Mastering Diabetes, who are 2 great guys who are treating type 1 diabetes with a fruitarian diet. And one of the things that that podcast may or may not be out when this one comes out. Whenever I do a podcast with you, it always burns a hole in my hard drive because I think this is great information. I got to get it out to people. But one of the things that is sometimes leveled against ketogenic diets, quote, by people who are favoring high carb, is that ketogenic diets cause insulin resistance. And I think this is very misleading and overly generalized. So let's dig into this and help people understand the difference between pathological systemic insulin resistance and what we might call glucose sparing at the level of the muscle, which is a normal physiologic phenomenon during a low carbohydrate diet.
Yeah, so I think where this all starts is with a misconception about what insulin does, and then conflating 2 very different states, physiological states. And so, like we talked about, the main role one of the main roles of insulin in my mind is anti-catabolism, which means that it stops you breaking down tissue. Everybody thinks that the role of insulin is to shove glucose into cells, and I think that is the case because that we discovered insulin and we focused on insulin because of type 1 diabetes and the treatment of type 1 diabetes. In type 1 diabetes, you have to take exogenous insulin. You have to inject it because you're not making any. And in that scenario, you're injecting insulin peripherally, at a dose that will push glucose into cells. One of the ways that it controls blood sugar, though, is by acting on the tissues, muscle tissue, fat tissue, to not break down and deliver gluconeogenic substrate to the liver. So the liver is making a lot of this glucose, and then you're stopping the supply of substrate because unabated, no insulin, your muscle starts to break down, your fat starts to break down. The amino acids, fatty acids, glycerol are just delivered to the liver, and the liver's like, crap, I better make glucose out of this because that's all I can do. And again, there's no insulin, so there's no brakes on the liver doing that. So the liver just pumps out all this extra glucose. And all of this is kind of conflated because if you inject insulin and glucose goes down, you're assuming, oh yeah, that's because the glucose has been shoved into a cell. It's not just that. It's also that the liver is making less glucose. And in type 2 diabetes, that is where most of the glucose is coming from, is unabated gluconeogenesis in the liver. And that is happening because the fat tissue particularly, but also potentially the muscle tissue, is insulin resistant. It is said, no more insulin for me. I have enough energy on board in my cell that I'm not using. So you can't shove any more into me. And then you get to a point where they start to break down. You have amino acid turnover in the muscle. You have fatty acid turnover in the adipose tissue. And those are then delivered to the liver, which again has this, it's partly supply driven. Like this stuff just shows up and it's like, well, what am I going to do with it? It's glucose is less toxic than having loads of glycerol and free fatty acids and all this stuff just like floating around. So I'm going to turn it into glucose. And this is why the states are so different in physiological insulin resistance, where blood glucose is low because you're not getting any in through the diet. And then you have tissues, particularly the muscle tissue, which can adapt to using free fatty acids released either from the diet or released from the adipose tissue if you're in a deficit. And then there are some tissues in the body that do have a requirement for glucose. They can't fat adapt, particularly certain cells in the brain and the red blood cells. So you need whatever glucose you have to be spared for those cells. So the muscle tissue says, do you know what? I can run on fat, so I'm just going to turn off this insulin signal, and you don't need to give me any glucose because I'm sparing the glucose for the rest of the body. And in that state, yes, you will also have elevated free fatty acids like you do in type 2 diabetes, but you have very low glucose. So there's a completely different states. This is the body. And because of the role of insulin, this is the body deciding which nutrient should go, because nutrient partitioning is insulin's essentially its main job. And that is insulin acting correctly. In that state, you don't have enough glucose to run all the cells in your body. So the body selectively says, this can run on fat, this needs glucose, so it's going to be spared for those tissues. But what happens is then if you give somebody a boatload of carbohydrate and they've been on a ketogenic diet for a long period of time, those cells have still turned down the insulin signal, right? So you're going to get this massive spike in blood sugar and say, holy crap, this guy has insulin resistance. But if you had them eat some carbohydrates for 3 or 4 days, this is probably somebody who in that interim improved their, particularly if they were overweight or insulin resistant before, they improved their body composition, potentially maybe lost some weight. Their metabolic health has almost certainly improved, but you just need to give them some carbohydrate for them to like turn that signal back on.
So it's complex physiology. We really need a whiteboard, a lecture. But I love this conversation. So what Tommy is saying, I'll just try and summarize it or regurgitate it for people in a different way, and hopefully it'll become even more clear. During states of low carbohydrate consumption of a diet, the body does something which is natural called physiologic insulin resistance at the level of the muscle, or glucose sparing is probably a better word. And so what's happening there, and there are studies which show that even one low carb meal at night can do this. And so pregnant women who are doing a glucose tolerance test or a glucola the next day should not be doing a low carb meal, or they can do a low carb meal if they want to. But if a pregnant woman does a low carb meal the night before a glucose tolerance test, they can look insulin resistant the next day because that test is sort of flawed, right? And what's going on there is that when we increase the amount of fat in our diet and when we decrease the amount of carbohydrates, there are different signals from the adipose tissue because of declining levels of insulin, right? So what we know is that if we don't eat carbohydrates, if we eat a high fat, low carb diet with a moderate amount of protein, insulin signal drops. And when the insulin signal at the adipocytes drops, they change the fatty acids that they put out into the blood. And it shifts from, correct me if I'm wrong here, palmitoleic acid to palmitate. And then palmitate circulates to the muscle cells and kind of gives them the signal, hey, refuse glucose. We've got plenty of free fatty acids. Spare the glucose for the brain and the red blood cells. And this is physiologic insulin resistance, quote, which should be glucose sparing. This is a very different state because in this glucose sparing state, as you said, insulin is low, glucose is low, right? And it's really only the muscle that is refusing glucose. It's not, and it's really only the muscle that is becoming resistant to the actions of insulin or saying, hey, I'm not going to listen to you, insulin. I'm going to do my free fatty acid stuff, right? And it doesn't have to really listen to insulin as much because insulin levels are very low in terms of glucose partitioning. But in type 2 diabetes, it's a very different situation. And as you and I have talked about, insulin resistance, systemic, pathologic insulin resistance, I want to talk about what you think causes that. But I think one of the main things that causes it is mixed carbohydrate and fat overfeeding. So we get lots of calories. The adipocytes are stuffed full of lipids. And the adipocytes are saying, whoa, I am full to my brim. And the adipocytes become insulin resistant. They refuse the actions of insulin. And the adipocytes are initiating this cascade. And they're doing the same thing, which is why it looks confusing. They're shifting to palmitate. They're telling the muscles to stop refusing glucose and the signals of insulin. But it's coming from the adipocytes because in many situations, they are overfull of calories in the form of fatty acids. And in that situation, insulin is high. And glucose is high, right? And so when I was trying to talk to the guys on this podcast from Mastering Diabetes, I said, we cannot define insulin resistance independent of levels of systemic insulin because glucose sparing is low insulin and systemic pathologic insulin resistance like type 2 diabetes is very high insulin, which is why we check fasting insulin, why we check C-peptide. And that's a very good sort of indicator whether we're in a state of low carb, high fat, normal, or we're in a state of hyperinsulinemia. So if we are insulin resistant or the body's not getting a whole lot of signals at the liver, at the adipocyte, in the muscle when insulin is low. It's still getting some. And you and I have talked about how insulin signaling is not entirely driven by absolute insulin levels, that things can change at that level. But if there are high levels of insulin in the body and things and tissues are not responding to insulin, that is physiologic insulin resistance. And that is the case in which glucose is high. Oh, that is pathologic insulin resistance, right? We need better terms. Thank you. That is pathologic insulin resistance. And that is the case that you're describing where the adipocytes are releasing fat and there's all these substrates coming to the liver and gluconeogenesis does appear to be at least somewhat supply driven. And the liver, as you said, is incorrectly gluconeogenosizing, like jazzercise. The liver has its headband on. It's got a big fro and it is gluconeogenosizing like crazy and making glucose from all this substrate. And that's what I love that you pointed that out, that high levels of glucose in pathologic insulin resistance are predominantly related to just the liver gluconeogenosizing like crazy, like because of the signaling that's different. So these are very different states. Did I say all that right? What do you think about that?
Yeah, I think that's right. The thing that really drives me crazy when people talk about insulin resistance is that they base this all on essentially what we call the euglycemic hyperinsulinemic clamp, which is basically that this is like the gold standard of testing insulin sensitivity. And what that involves is hooking you up with multiple drips, putting both glucose and insulin straight into your circulation and seeing how, if I give this boatload of carbohydrate, how much insulin does it take to clear that glucose, to like shove it into cells? And like when you do that, then physiologic insulin resistance or glucose sparing and type 2 diabetes will look very similar, but it's all based on this flawed concept that the job of insulin is to shove glucose into cells. So you're using the wrong test to really understand this, or you're not using it. You're not really using it in context, and I think that's where the big problem comes from. That the main test that we use, the gold standard, is based on a flawed physiological understanding of what insulin does,
or a limited understanding.
Yeah.
And as you and I talked about, there are multiple roles of insulin, and this was your sort of paradigm, that the first role of insulin was an autocrine effect in the pancreas, sort of limiting glucose. So why don't you just give people sort of your perspective on the some sort of hierarchy. What are the roles of insulin, and where does pushing glucose into cells fall in that hierarchy?
Yeah, so it does do that once the level is high enough. And so I think about insulin as it tours through the body. Like, where does it, if it's produced normally in the pancreas, where does it go first? And then what does it do? And in that order. So as soon as it's released in the pancreas, it acts to inhibit the release of glucagon, as long as the pancreas is insulin sensitive. And glucagon, obviously, being part of the signal telling you to break down tissue and activate gluconeogenesis in the liver. And so it does that. It suppresses glucagon secretion, and then it goes to the liver, where it alters turns gluconeogenesis on and off. Are you needing to make more glucose or less? And obviously, if you're in a ketogenic state, you will need more gluconeogenesis, and there is some evidence for that, because you're not getting that carbohydrate in the diet, and so insulin is low, more gluconeogenesis. And then it goes out into the circulation, and the first thing that it does is to suppress or be anti-catabolic in the muscle tissue and the adipose tissue. So when they've done nice studies where you basically inject insulin into like one limb, and then you look at the amount of a substrate coming in and coming out. So at the lower doses of insulin, you reduce circulating fatty acids. So the first thing that it does is be anti-catabolic in the adipose tissue, or start to cause the uptake of fatty acids from the circulation. And then to start finally shoving glucose into cells, you need to increase the dose yet again. So of all the things that insulin does, requiring the highest circulating amount, the final thing is glucose uptake into cells.
And that's what's focused on with the clamp testing, and that's, like you said, kind of a myopic, limited model, which excludes all these other functions of insulin and misleads us badly. So the take home here is low-carb ketogenic diets do not make you pathologically insulin resistant. They induce what's called glucose sparing at the level of the muscle, which is a perfectly normal physiologic phenomenon. So if you hear someone say a ketogenic diet makes you insulin resistant, Michael Greger, I'm still waiting for you to show up on this podcast, you fraidy cat. This is not true, and this is normal physiology, and it's very different than systemic insulin resistance.
Yeah. So
let's talk about what causes insulin resistance. This, to me, is the $64,000 question. Listeners are probably not old enough to know about that show. Basically, this is the $1 million question. That was a show in the game show when $64,000 was actually
a lot of money.
A lot of money, and not just a half of a Tesla or something, like enough to buy like a reasonable car. So how do you think about this? Because what we know is that we do not want to be insulin resistant, pathologically insulin resistant.
Yeah.
So what causes this?
So I think the cognitive framework that I use, and it's by no means complete, but the cognitive framework that I use is essentially that this is controlled by our adipose tissue. So it's the fat that becomes insulin resistant first. And there are multiple really interesting things that control this. So there is, at some level, a genetic effect or an ethnic effect, because we know that people of different ethnicities can get a certain amount of fat before they become insulin resistant. Caucasians were amazing. We can stuff a whole boatload of fat into our bodies before we get type 2 diabetes.
You mean we can store the fat?
We can store the fat.
Tissue can expand.
Yeah, exactly. And we can get
not dietary fat per se.
No, not dietary. We're talking about how much fat you're storing.
Adipocytes can expand.
Yeah.
Right?
So Caucasians generally can get the fattest, again, on average, before they become insulin resistant. Whereas people of different, South Asian populations, they can get less fat before they become insulin resistant. And so there's some kind of threshold at which the adipose tissue says, no mas, I can't take any more, and it stops listening to the signal. It becomes insulin resistant. there are modifiers, which is why that is the personal fat threshold is certainly not enough to explain what's going on. And we know from experiments things like metabolic endotoxemia. So if you inject people or mice, rats, humans with LPS, so the endotoxin from E. coli, which we will certainly be exposed to it, if our gut barrier isn't working properly, probably even a little bit after every meal, then chronically you start to see a change in the fat tissue. So there isn't as much of it, but it starts to look like insulin resistant fat tissue, which has a lot more macrophages, a lot more white blood cells. It's a lot more inflamed, and the cells are smaller but more inflamed, and they're insulin resistant. So if you have anything, I think that's causing a chronic systemic inflammatory state, then that is going to modify how much fat your cells are willing to take up before they start becoming insulin resistant. And you see this in people with different autoimmune conditions. So Sjogren's, rheumatoid arthritis, they are generally not overweight, but they are very insulin resistant. And there's probably an interaction between, the amount of adipose tissue they have and the amount of systemic inflammation that they have going on. So the first thing that happens, I think in most people, you can probably become insulin resistant in your muscle tissue first if you just sit all day and do not move that muscle at all. But generally, I think the fat becomes insulin resistant first, then it starts turning over fatty acids like we talked about before. These go through the portal circulation to the liver. All this stuff just starts showing up, and the liver starts saying, fine, I just have to start turning this stuff into glucose. And that's that's where the whole thing starts.
I love it. That makes so much sense to me. And I totally agree with you that it all starts with the fatty tissue. And so I think of this as there are two main ways to become insulin resistant, or there are two sort of pieces to this equation that you talked about. There's what we take in our diet. And it does look like, to me, you can eat yourself into insulin resistance. I think we're pretty clear that you can eat yourself into insulin resistance. And to me, it looks like, based on the Randall cycle and other biochemistry, which we don't have to go into here, if we consume fat and carbohydrates in excess, which is basically extra donuts, right? The easiest way to consume fat and carbohydrates in excess is to eat processed food, which is often fat and sugar in excess. We will eventually get to our personal fat threshold, at which the adipocyte says, whoa, no mas, and we become insulin resistant starting from the adipose tissue. But I love that you put that in the context of inflammation, because we know that inflammation independent of diet can cause insulin resistance. And that the inflammation gives sort of the context for the adipocyte to say, what is the adipocyte threshold at which that adipocyte is going to become insulin resistant? And so, like you said, in people with inflammatory disorders, they get insulin resistant sooner. I think this is one of the fascinating things of dietary change inducing insulin resistance. It's probably a combination of, can we affect decreasing levels of inflammation by removing inflammatory foods, processed food, or in my opinion, perhaps some plant foods which are triggering inflammation in the gut, who knows? And can we create temporary caloric deficit, or stop overfeeding people, or stop the sort of physiology that leads to this adipocyte overfeeding as we're stuffing extra calories into people? It's very clear from many of the studies that you and I have both looked at that when we overfeed people mixed macronutrients, they become insulin resistant in the same way, because the adipocytes are just totally full.
Yeah, you can start to, in the Western, sort of a Western style diet overfeeding studies, you can make somebody insulin resistant within a couple of days by just overfeeding them a Western style diet.
So they don't even have to get super fat.
No. And that's probably an inflammatory effect as well, because if you look at, certain, I think refined sugar, certain oils, they've been shown to increase metabolic endotoxemia, increase LPS transduction across the gut lining. Of course, saturated fat, liquid saturated fat is also really good at that. And, I think we talked about that last time I was on the podcast. So anything where the diet has become more refined is probably going to start, worsening those states. And that's probably where some of that very quick early insulin resistance comes from, is that the structure and type of the diet and some of its components are increasing systemic inflammation because it's altering the permeability or the function of the gut.
Yeah, I think that's a really important point. And I should have said this in the beginning. This is Tommy's third appearance on the podcast. So if you want Tommy Wood number 1, you can go back to that one. There's also Tommy Wood number 2, where we talked about ApoE4. And this is Tommy Wood number 3. I did a podcast with Ivor recently, and something came out that was quite interesting. And it really made me think of this conversation that we had, Howard, regarding processed fat, liquid fat. And Ivor was mentioning that when food hits the stomach or when fat hits the stomach, we will release GIP. And that is a different incretin or hormone than GLP, which occurs further down. And then further down in the gut, we get PYY. And these are just acronyms for different incretin or hormones in our digestive system that control insulin sensitivity and satiety. And what Ivor was saying was that if we eat processed food, if we eat carbohydrates or fat, potentially, which is processed, meaning liquid fat or processed carbohydrates, a lot of it gets digested and absorbed early on in the gut. And so we only get GIP without balancing GLP and PYY. And that can affect satiety and insulin sensitivity in a different way. I thought that was so interesting. And it really argues for, man, maybe we should not be eating liquid oils.
Yeah.
You and I talked about that on the first podcast. I very much prefer real fat, quote unquote, in my diet. That is like a ribeye cap, fat from an animal that's encased in connective tissue. I don't recommend this to people on a carnivore diet or really any diet to do tallow, which is kind of that rendered fat, right? Or to eat it in limited fashions. But these are things like butter. This is processed liquid fat.
Bulletproof coffee is my favorite one to slam on. Yeah.
You just love to hate on Dave Asprey.
So I mean, this is this is really important, and it leads into the fastest way to reverse insulin resistance is to get a gastric bypass, because you're then delivering that food much lower down into the gut, and then you almost immediately normalize some of that incretin physiology. So even without people
out of surgery,
people without losing any weight, they all of a sudden become much more insulin sensitive because you're now delivering food to the part of the gut that is expecting it at the right time.
And then this is kind of the balance between GIP, GLP, and PYY, and probably other incretins. And so it's getting food to that latter part of the gut that might be crucial, right? Like that might be a big piece of this. And this is the problem with processed foods and oils, even if it's tallow potentially for humans, or butter coffee, or lard, is you may not be getting the right succession of incretin hormones in the gut.
Yeah.
It's so that's such a fascinating concept. And for people that are not familiar, gastric bypass is sometimes done with what's called a Roux-en-Y procedure, where a large portion of the small bowel is raised up to the stomach and they create a blind loop. And as Tommy is suggesting, basically it's like, instead of the stomach leading to the duodenum, the stomach leads to what? The jejunum.
Yeah.
Right? And so the jejunum is the second portion of the small bowel. So you move out of the stomach, you go into the duodenum, and then it goes to the jejunum, and then to the ileum, which is the terminal part of the small bowel. Many people will know that the small bowel is 20 to 30 feet in length, and it's just all these guts in you. And that middle part of the small bowel has different hormonal signaling. And if you don't deliver food there properly, because we're eating food that's too processed, ground up, things like this, it can change our physiology. What a fascinating concept that is, huh?
Yeah, and it's really interesting. If you look at there's a reasonable amount of information, particularly on carbohydrate foods, but beans and potatoes and other starchy products. If you look at how processed they are, the amount of those hormones that are released, even though it's exactly the same food, but how much you've ground it or boiled it or really reduced it to its component parts has a very different effect on your physiology. So how food is processed really changes the hormones that are released as part of it. That changes how much insulin is released, how much glucose circulates, your satiety. So when people are talking about diets and talking about the caloric balance is what determines whether you gain or lose weight. Yes, that is true, but what you do to that food changes your physiology such that it changes how much you eat, when you eat, all those other things that are then going to alter your caloric balance. And that all happens because of the state of the food and then the hormones that are released because of it. But changed massively just by processing. The food can be exactly the same, but you process it highly, has a very different effect.
So just so people know these hormones that we're talking about, GIP is gastric inhibitory polypeptide. GLP is glucagon-like peptide 1. And GIP is secreted from the K cells of the upper small intestine. And then GLP, the glucagon-like peptide, is much further down. And then PYY is a hormone that, again, is much lower down. And I'm looking for the acronym. What does it stand for, Tommy? PYY. Peptide YY.
Yeah.
Peptide Peptide YY. Okay. Anyway, I think that's just such an argument. Like, don't eat processed food. Don't eat processed food. Like, don't eat processed grain. Don't eat processed oil. Don't eat processed meat.
Yeah.
And it makes me think like, well, what if we make a protein powder? Does that affect our gut differently? Probably.
Yeah. So it definitely that affects physiology too, like the state that the protein comes in. I use protein powders. I think that particularly for people who are trying to get in enough protein and in various athletic pursuits, it's fairly well supported. But yeah, by processing the protein, you will end up with a different physiology as a result. We know that.
I think that, this is such cool stuff. So that's the discussion of insulin resistance. So to avoid it, we look for a healthy body composition. To this, I wanted to add that some of the populations that become insulin resistant at much more lean body mass are Asians.
Yeah.
And this is why it can be so misleading. And that people have talked about this on other podcasts, that Asian populations can look from the outside like they are thin or svelte, but they can have raging insulin resistance. For whatever reason, in Asian populations, that threshold at which the adipocyte tops out is much lower. But like you said, Caucasians, we can get real fat before we do that, which is maybe, who knows whether that's protective or not.
Yeah, I always use, I stole this from somebody, but I can't remember who it was. But there are two ends of the spectrum. One being the sumo wrestler, which actually, obviously, usually of Asian descent. These guys are super fat, but very insulin sensitive, at least while they are training all day, eating all day. They actually eat a very high carbohydrate, low fat diet on average. So, there's no substrate level competition, which I think is probably helping them because they're in a huge caloric surplus. They're very fat, very insulin sensitive. At the other end, you have people with lipodystrophy who cannot store fat, right? They have a genetic mutation, which means that their adipose stores just cannot expand. These guys are super ripped and they are super insulin resistant, right? They just cannot store any fat. They have no physiological buffer for the calories, both to store and then release, as we eat and don't eat. And they're just like insulin resistant basically from birth because they don't have adequate fat stores. So those are the two ends, and you can do both. And then there's various reasons why that happens. But so those are the things that can sort of manipulate the system and show how important the fat tissue is to whether you are insulin sensitive or not.
And I love that you highlighted that about sumo wrestlers, that it's a high carb, low fat diet.
Yeah.
I wonder what would happen if you gave a sumo wrestler a mixed macronutrient diet. Would they instantly become insulin resistant? Because that's kind of what we're talking about. And we've talked about studies where you can do pretty massive carbohydrate overfeeding in the absence of fat. And again, this is individual basis, and not really develop great insulin resistance immediately. Yeah,
they did this, the bagel study, but where they gave people, and they were mainly, so the vast majority of the calories came from carbohydrates. It's more than 90%, I think. And they were trying to see how much carbohydrate it would take to initiate gluconeogenesis, de novo lipogenesis, and start gaining fat. And what happens is their metabolism just increased. So more carbohydrate went in, the basal metabolic rate went up, and they just started burning those carbs off. Right? They weren't turning them into fat or storing them. So as these guys went through the study, they had to feed them more and more bagels every day as the metabolism went up and up and up until they reached a threshold, which was several thousand calories a day of bagels just to start to see this. But it was in the context of essentially a fat-free diet. And so if you're eating just carbs, you will just keep on turning up the metabolism until you burn them off. But that's not what most people are doing. If you then add some fat to that diet, all of that fat gets stored immediately because you have so much carbohydrate that's what's going to get used first.
And so this is quite interesting. Obviously, long-term bagel diets could be quite micronutrient deficient.
Yeah.
Not a good thing for humans. But this is fascinating human physiology, that really to do de novo lipogenesis, which is turning carbohydrates into fat, we need to have some fat in our diet.
We need to just get to a point. If you only have carbohydrate in the diet, you need to get to massive amounts of carbohydrate before you'll start to turn that into fat.
Right.
But if you have fat in the diet and you're eating a load of carbohydrate, that is what's going to get stored as fat. So it's just storing the fat that you ate. But in general, in the Western world, the fat on your ass is the fat that you ate. Right? That's just we can measure it. Right, this is the fat that's in your diet.
We can do tracer studies.
Yeah, and this is the fat that you ate, and this is the fat that you stored. And that's because you're in this state where you're eating a large amount of carbohydrate, and a large amount of fat, and you're in a caloric surplus. So like all of that stuff just starts getting stored.
And so this is kind of what's so fascinating. This has come up a lot on my podcast, the magic of either low carb, high fat diets or low fat, high carb diets.
Yeah.
Right?
And I think both work, like in the setting of somebody who's like metabolically unhealthy, I think both can work, right? There's
to improve that.
Yeah, to improve that metabolic state. And it's much more likely you'll enter a caloric deficit because you've dramatically reduced the amount of food that you can eat. You will, when anybody goes on any kind of restricted diet, they automatically reduce the number of calories they eat just because all of a sudden all these things that you ate just disappear from your diet, and then you have to find ways to hack your way around it. And that does happen eventually. But that's one of the reasons why any restrictive diet will usually cause weight loss, is because you just don't eat as much.
Yeah. And I think then the arguments or the discussion becomes, which is better,
Yeah.
And where do you get your nutrients from? Which is one of the things that's fascinating for me about a no-till carnivore diet. It just seems like, man, high fat, low carb with animal foods really gives me more nutrients than a high carb, low fat diet would for a given amount of protein. But I guess I'm favoring, fat soluble nutrients in the fat that I'm eating over fiber from the carbohydrates.
Yeah.
And the sources of animal fat that I'm eating. So that's cool. It's fascinating discussions there, man. It's so crazy. So I think that basically what would happen is we give a sumo wrestler a little bit of fat, boom, they just explode in insulin resistance.
Yeah, obviously they'll have some fat in their diet, but the other important thing about their diet is generally, and obviously I'm not super up to date on sumo wrestlers, but from what I know, it's not a very processed diet, right? It has
rice.
It has rice, huge amounts of broth, but also lean meats. Vegetables, they're poisoning themselves with all that, with all those polyphenols. But they're eating, compared to what most people eat, a fairly unprocessed diet. And so even then, in massive caloric surplus, low fat, unprocessed, they still maintain insulin sensitivity. The problem is then when the sumo wrestler quits sumo wrestling, just like when the NFL lineman stops playing football, right? Bam. Suddenly insulin resistant. So you need those muscles like to be working to offset that. But while they're still working hard, having all that fat, they're still insulin sensitive.
And the people with lipodystrophy, do they get cardiovascular disease?
Yes, absolutely.
Very aggressively,
Yeah.
right? So this is, again, Tommy and I are not necessarily talking about cardiovascular disease and LDL in this podcast. I did a previous one with Ivor Cummins. I did 2 with Dave Feldman. But what the takeaway from those podcasts was for me, and Tommy and I agree on this, is that insulin resistance is the spark that lights the fire of cardiovascular disease. And so people with lipodystrophy, I wonder what their LDL is, to tell you the truth. I wonder if they looked at lipid panels in people with lipodystrophy.
I'm sure they have. I don't know the answer, but I'm sure they have. Yeah.
But what's so interesting is I believe you and I have talked about this, that people with lipodystrophy, right, look ripped, very insulin resistant below that, aggressive cardiovascular disease.
Yeah.
Because it's insulin resistance that really is the determining factor in whether we develop this atherosclerotic cardiovascular disease process. So, all right, we've got a few minutes left and then we got to run. Let's just touch on this one thing and then we'll wrap it all up, my man. We could talk for hours. We'll do probably 6 more of these. Let's talk about sodium and potassium. So we're going to shift gears here. Let's talk about electrolytes a little bit. You and I were kind of rapping about this in the gym. I'd love to get your thoughts on this. One of the criticisms of low carb, high fat diets is that there's not enough potassium to balance the sodium.
Yeah.
And so what's your take on this?
Yeah. So I think that's potentially true. Again, it depends on the context of the diet. So when we think about sodium sensitive hypertension, people are really worried about it in terms of their blood pressure. Most of it happens in the context of a relative absence of potassium and magnesium from the diet, right?
Like a complete absence.
Just a complete absence. So if you're eating processed foods, right? So in your body and in every other thing that you're eating, potassium is inside the cells, right? And so when you start to process that potassium is lost. So in a highly processed diet, is it working? In a highly processed diet, there's basically all that potassium falls out. It's the same thing like if you cook your steak to within an inch of its life, those cells are going to start to shrivel up, burst. That potassium is going to be lost. Those juices that you leave on the plate, like that's all your potassium is just like disappeared.
Drink the juice.
Yeah.
I always drink the juice.
And so this is the problem, is that high salt in that context is potentially problematic for some people. For some reason, not everybody. But if you balance out the potassium, then the sodium doesn't seem to be a problem. And magnesium as well, obviously very, very tightly linked to that as well. So if you're getting enough of those minerals, then I don't think there's really a problem there. But that just means that you need to not be overcooking your meat, the juices, making sure that you're actually eating, relatively fresh, unprocessed versions of those foods. And then you should be getting absolutely enough potassium to balance the sodium in the diet.
And so you and I were kind of talking about this in the gym. I just want to drill down on this. Do you think it's sodium potassium ratio, or that it's sort of an absolute amount of potassium that we need to get? Because for myself, I'm getting a lot of sodium on this diet.
Yeah.
Right. So I have definitely found that on a low carb diet, 10 to 12 grams of sodium chloride a day, which is 5 to 6 grams of sodium per day, helps with everything. And I've sort of been trying to figure out what is the ideal amount of sodium and or sodium chloride in my diet. And some people might say, well, you need to balance sodium and potassium 1-to-1. So you need to have 5,000 milligrams of potassium in your day, which is basically impossible.
Yeah.
Now, I will point out to people that I probably get close to 3,000 milligrams of potassium a day. So I'm not that far off. I'm getting probably 5,000 or 6,000 milligrams of sodium and probably about 3,000 milligrams of potassium in meat, because a pound of meat has 1,400 milligrams of potassium. I sometimes eat between 1.5 and 2 pounds of meat plus organs. There's a decent amount. There's a very robust amount of potassium. Meat is actually a fantastically rich source of potassium.
Yeah.
Gram for gram, I showed a graphic yesterday in my talk that meat has as much potassium as anything else out there, whether it's like kale or blueberries or any other vegetable food. There's as much potassium in meat, gram for gram, as there is in vegetable foods. So do you think that it's about that if I get an absolute amount of potassium that's reasonable for my body to do its thing, that high amount of sodium is a problem, or it's going to balance out?
I think it's probably going to balance out. And I think, yes, the ratio of sodium to potassium is probably important in the context of where we're studying this stuff. So in a high carbohydrate diet where insulin is high, which causes greater sodium retention in the kidney, more of the sodium that you eat is going to be recycled back into the body. It's going to keep sodium levels high. Therefore, you need to somehow hack your way over that. You probably need to add more potassium. In a low carbohydrate, low insulin state, higher sodium, you're probably going to lose a bit more of that sodium in your urine. Not a problem. And then you're going to be getting plenty of potassium. 2 or 3 grams a day is probably going to be plenty, as long as you're eating like fresh foods, right? If you were only eating bologna and you cooked all of your meat within an inch of its life, that's not going to be the case. But that's not the way that you're eating. So as long as you're still getting the potassium from those foods, I think you're absolutely getting enough.
And you make such a good point there. Sodium intake is not an absolute number.
No.
Sodium intake can be affected by a low carbohydrate diet. And so I'm intaking 5 grams of sodium or 6 grams of sodium as 10 or 12 grams of sodium chloride. I'm probably losing a little bit of that. And so my actual sodium potassium balance might be more toward what people are imagining.
Yeah.
Some people in the space have suggested, I'm going to have Lauren Cordain on the podcast soon, that we had ancestral ratios of potassium to sodium that were 3 to 4 to 1. And I think that's a little bit far-fetched. I can't imagine that we were getting that little sodium and that much carbohydrate or that much potassium. And I do think that there's an overarching thing here, and we can't use sodium potassium ratios as absolute. There's a lot of contextual stuff here having to do with insulin signaling as well, and overall sort of insulin sensitivity. Yeah,
if you look at the studies that I think he's basing some of that on, so some of the original Connor and Eaton studies on the Paleolithic diet, they were studying hunter-gatherer diets that had a relatively high carbohydrate content, and I think that's going to cause some sodium sparing. So I think it's very much going to depend on the other factors of the diet, whether we really need to worry about that.
Yeah. All right, man, we should wrap it up here. Where can people find more of your stuff? You're kind of like under the radar. You just want to be secret. Do you want people to find you?
Yeah, people can. I quite enjoy just talking to interesting people. Maybe I'm a resource to some people who are a little bit more out there than me, and I kind of enjoy that. I don't like being like the go-to expert. I find it very stressful, and it's sort of people constantly asking me questions. I've done that in the past, and it's sort of like I don't really enjoy that. I'd much rather just have interesting conversations with people that I know and respect. So, but you can find me on Instagram at Dr. Tommy Wood, at Dr. Ragnar RIGNAR on Twitter. I spend a lot of my time now like doing research and writing papers, so you'll probably find me on PubMed more than you'll find me on Twitter. But that's kind of the life that I lead.
Do you still work with clients?
Yeah, occasionally. I try not to. I try not to really push that side just because I don't have a lot of time for it. But occasionally, I'll get it's usually now come from referrals. So somebody who I know and respect, another physician or practitioner is like, "Hey Tommy, I could really help you out. I really use your help on this case. Do you mind like jumping in and like giving some advice?" And that's usually what I end up doing more of now.
So if people want to work with Tommy, they got to talk to me.
Go and find one of my physician friends and then ask them that you would like my input. Yeah,
and I want to mention that we are at the Physicians for Ancestral Health conference this year in Scottsdale. And if there are physicians or people who are interested in this is a really fun conference. It's a small conference. It's very intimate, but it's a great group of people. So I would recommend people check this out. I'm sure that it'll be next year, about a year from now, or in January of 2021. But people should definitely check this conference out. Physicians who want to come, it's such a good group of people here, and it's really, you call it a retreat. So I would encourage people to really check this out. I'd love to see more people here. I'll probably be back next year because it's really just a cool community of people that are super smart and thinking about things from an ancestral lens. So I'd love to see more people here next year, and maybe
come and join us. Absolutely.
Yeah, maybe it'll be a common occurrence. So last question, we always get this one. I'm peering over at my Zoom recorder. It's going to die any moment. We'll see if this actually gets recorded before it dies. What is the most radical thing that you have done recently, my friend?
You always catch me out on this. I mean, I know that it's coming, and I never think about it. What's the most radical thing that I've done recently? Do you know what? Maybe it's not. I've led a pretty sheltered life as I've been trying to like catch up on all my academic stuff. But I've been doing a lot of training in the cold. In Seattle, it's like freezing, below freezing. My gym is in equilibrium with the outdoor elements. It's essentially just like a metal shed with all the stuff in it. So I'm usually out there. It's freezing cold, snow outside. Getting the music turned up, doing the squats, even though the weather's bad and the gym's really cold, and I really kind of enjoy that. So that's probably some of the more radical stuff I've been doing recently.
That is so consistent with your ancestry. You are such a freaking Viking, dude. Like, that is exactly what your ancestors were doing, was humping around big freaking rocks.
Yeah, in the freezing cold.
In the freezing cold. Yeah. So that is the theme of today's podcast. Be ancestrally consistent. Don't eat polyphenols that your ancestors would not have had, and stop eating.
There's a lot of coffee in Norway now, maybe not 1,000 years ago.
1,000 years ago. Who knows? Thanks for coming on, my man.
Thank you.
All right, everybody. Thank you for listening to that episode with Tommy Wood, Dr. Tommy Wood on Instagram. Give him a high five. Tell him what's up. Next week's episode is the second part with Tommy Wood. Like I said in the intro, it is a two-parter. The first part was recorded in January. The second part was recorded in July. And the second part goes even deeper into all of these amazing nuances regarding insulin resistance. Do not miss next week's episode. Do not miss it. It is amazing. And I love Tommy with my whole heart. So thank you to my sponsors. Thank you to Force of Nature Meats, forceofnature.com. You can get amazing, regeneratively raised beef, bison, elk, venison. It is so cool. Check these guys out. WhiteOakPastures.com. Carnivore MD there for 10% off your first order. Nutrisense.io. Get your CGM, change your life, know what your glycemic variability is. And my book, thecarnivorecodebook.com. Second edition is coming out on August the 4th. And it's going to cause a stir. And I think we're going to help a lot of people and change a lot of lives for the better, which is the ultimate goal. So appreciate you all. What is going on with me? I am living the life in Texas. I am digging this place in Texas called Ocean Lab. If you guys are here, shout out to Ocean Lab. I go and almost every weekend do a sauna and floating and cold plunging. In fact, most days of the week I will go float now. I'm loving how it helps me turn off my brain. So check out Ocean Lab if you are in Austin, Texas. I love these people. There's an awesome group of carnivores here in Austin. So if you want to join our Facebook group, it is Keep Austin Carnivorous. Keep Austin Carnivorous. Tell them I sent you and come hang out with us in Austin. We would love to have you join the tribe. But I'm digging it here, guys. I'm loving the sun and the water. Been working really hard on a bunch of projects I've got coming up, which I will be telling you about in the next 2 weeks. The unveiling happens so soon. Stay ready for awesomeness, for more radicalness. It's coming. You thought the book was the only thing. I have so many other amazing radical tricks up my ribeye lined sleeves. So that is all so cool stuff. I'm getting in the sun. I'm working out, going to 10th Planet in Austin. Shout out to them, doing some striking and getting back to the jiu-jitsu mats. Loving that. Just digging it here in Austin. Really good people. So I hope that conferences will be back and rolling next year and I can meet all of you here. But that's what's going on with me, you guys. Books coming out, new exciting project that I believe in deeply with my entire heart, coming in the next couple of weeks. And yeah, so anyway, stay radical. Please support the book. Leave me a review on Amazon. Please leave this podcast a review on iTunes or wherever you listen to it. Share it with your mamas and your papas and your grandmas and your grandpas and your brothers and your sisters and your sons and your daughters. Because ultimately, the reason that I do this is because of my niece and nephew, my brother, my sister. I don't have a brother, but my brother's out there. My brother's from another mother, but my real sister, my mom and my dad. My grandparents are watching down from the big ribeye roast in the sky, but I believe that the health of my family, my tribe, and all of you is something that is deeply meaningful to me. And I fear there is so much misinformation out there that I just hope to be able to humbly add any piece of truth to that, any discussion point, any independent idea or recreated idea from someone else that is something that I can offer in a new way that will bring people to better life and deeper happiness. So that is why I do what I do. And if it's valuable for you, I so appreciate you sharing that with other people in your lives, because who knows why we're on this earth and how long we're going to be here. But I think that the more richly that we can experience these breaths, the more stories we will have when we go to the next phase of our lives. Who knows what that is? Anyway, getting all metaphysical on you guys. I'm going to end it there. Stay radical. I can't wait to share the next week's episode with you. I love you all.